In this video, we will talk about PSC theorem. I'm not sure like how to pronounce it, but I think it is pronounced as Pacelc theorem. It is basically an extension of Cap theorem, which we already saw in the previous video. So let us start with the quick revision of Cap theorem before we deep dive into the Pacelc theorem. So if you remember, like if we have a cluster of servers which are serving our customers, and in case there is some broken link or like some issue between the communication of two servers, there will be a partition happening between the servers. So at that time, they cannot communicate with each other for maybe some time. So that's why whenever we have a network partition happening, so then we have to choose either consistency or availability, because these two cannot be applied at that time. Because whenever we have partition happening in the system, systems cannot communicate with each other. So if you are choosing the consistency, at that time you have to let go the availability, because if a server A is doing some update and it can't propagate that update to server B, at that time if a request come to server B for same data, it can't respond because it will be having data which is stale, not the current data. So at that time, you have to make your system unavailable to serve your customers. But if you want to make it available, so at that time, data might be inconsistent, because whatever updates are happening in one server cannot be sent to the other server. So you have to choose it wisely. Like for example, we'll discuss that for the bank system, we have to choose the consistency. But for the any social media like Facebook or YouTube, we can choose availability. So you have to choose any these properties based upon your use case. There is no generic rule which anybody can tell. So now let's go to the Pacelc theorem. So Cap theorem talked about whenever there's a partition happening in system, right? So at that time, Cap theorem is applicable. But suppose there's no partition, nothing is broken in the communication link, and servers and everything is running smooth. So at that time, whenever there is no partition, then there are two properties which you have to choose, like latency or consistency. Let's understand it by an example. So suppose you have a main server, like a master server or master database, and then you have two replicas, like you have a single master application setup, right? So the requests are being served by the master, but you are updating the slave or replicas as well in the background, so that you have some backup ready. So at that time, in this scenario, when user want to have some request processed by the system, at that time, if you are choosing the consistency at a high level, I mean, you want like high consistency, and also you're okay with high latency, at that time, when request is going to the master server, it is going to update all the replicas at the same time. So whatever processing is being done by master, that is going to be in sync in all the replicas server. Then after the you will get response from the this server, right? So with this, what is happening that all these servers in the system, either it is master or the other replicas or slave servers, they are always inconsistent, right? So whatever data is being sent to master, it is also being sent to the replicas. So system is highly consistent. But a drawback is that there will be delay in response. So if you are choosing the high consistency, then you have to let go the latency. I mean, you have to bear it. So if in this scenario, we will get the high consistency and high latency for the user. On the other hand, if you want that your customer should get response in no time, so at that time you have to let go the consistency, because at that time you have to make sure that response is quick. So suppose you have same setup, right? You have one master and other replicas. So whenever a user sending a request to your system, at that time the master server will process the request and send back a response right away. So it will not update response or replica at that time. It will do it later. So for that, sometime the system become inconsistent because the master is not focusing to update data into other servers or the replicas. So here we are letting go the consistency. So in Pacelc theorem, you have to choose between the consistency or latency. If you want latency to be reduced, then you have to let go the consistency and vice versa. So let us understand both CAP theorem and Pacelc theorem in like a one diagram so that we understand it thoroughly. So suppose you have a system of servers which are serving the customers and there is no partition. At that time, uh, you have to focus on latency and consistency. So you have to choose between these two properties and fine tune your system accordingly. That belongs to the Pacelc theorem broadly. But in case there is a communication failure or network failure and your system servers cannot talk to each other, right? At that time, there is a partition happening. So you have to choose between availability and consistency. That is basically a CAP theorem. So remember these properties and when they come into play. So whenever there is no partition happening in the system is running up and fine, smoothly. At that time, you have to apply the Pacelc theorem concepts. And whenever there's a partition happening in the system, there is some network failure, then you have to apply the CAP theorem. So that's it for this video. Thank you very much for watching. See you next time. Please leave comments or questions. So I will try to respond to those questions. And yeah, please subscribe also my channel if you like it. And thank you so much.